Welcome to section 9.72, Systems of Inequality and Linear Programming, day 2. This is the linear programming part, and it actually has absolutely nothing to do with computer programming. I don't know why they even call it programming, or where the word program comes from. This is kind of a line of mathematics that was developed in response to needs in World War II. They were trying to ship lots of different things from the United States over to England in preparation for D-Day. And you can only fit so much in a boat, and you have to figure out exactly how much of all your different supplies you're going to fit. So it was kind of a question of maximization of things. And so what I'm going to do is I'm going to start off with a kind of an unrealistic problem that takes as tests like a multiple choice question and free response questions. It's a context that students might be kind of familiar with, even though the overall, you might not have ever been in this particular situation. It's kind of maybe you can relate because it has to do with multiple choice questions. So this is unrealistic, but I hope you can relate a little bit to the context. It's very much like it's example 12 in the textbook. You are taking a test in which multiple choice questions, MCQ, are worth 10 points, and free response questions, FRQ, are worth 15 points. It takes 3 minutes for each multiple choice question and 6 minutes for each free response question. So there's a time constraint, but they're also worth different amounts of points. And the total time allowed is 60 minutes. You have an hour to complete this whole thing. And you can't answer more than 16 questions. Don't bother asking why. It's just, we just need to do this in order to place the constraints we need. Assuming that all your answers are correct, which I know is kind of a big assumption sometimes as a student, how many items of each type should you answer to get the best score? So we have the option of choosing a certain number of free response questions and a certain number of multiple choice questions, and we have a time constraint, and we have a total question constraint. But we want to maximize the total number of points that we're going to get. So the strategy is basically going to represent all of these things as equations and inequalities. We're going to graph the inequalities, which we learned how to do last video. I'm going to find a region. Just to give you a preview, this is the region right here of acceptable values of x and y that will satisfy all of these, and then we're going to test the different parts of the region to see which of these maximizes the total number of points. We're going to do that at actually the vertices. The mathematics that came out of World War II planning basically said, well, you don't really need to do, you don't really need to test all the points in here. You only really need to test the vertices of your region. Let's start with the unknowns. The things we don't know is the number of multiple choice questions and free response questions. And I'm going to recommend, from a studentship point of view, that you always choose x and y to be these unknowns, because we're going to be doing lots of graphing on an xy coordinate axis. For word problems that we did in the last section, you didn't really have to do that because we weren't graphing, but we are specifically graphing here. So just to keep things easier, choose x and y. And make sure you label it. So therefore, because we're graphing and we're choosing x and y, it's kind of hard. Like, it would have been easier to remember that m is the multiple choice questions and like f is the number of free response questions. But all the more reason to write out this so that you can help keep track of which one is which. Total time, we can see is less than or equal to 60 minutes. We can't go over 60 minutes, but we can go equal to 60 minutes or less than. And then we also know the total number of questions you're going to answer is going to be less than or equal to 16. So we've got those two constraints. So rewriting them in terms of x and y, the total time, it says that it takes 3 minutes to do every multiple choice, so that's 3x, and then 6 minutes to do every free response question, that's 6y. So we can take this total time and graph it as 3x plus 6y is less than or equal to 60. Same thing with total questions. We know that x plus y is going to have to be less than or equal to 16. So these are two inequalities that can get graphed. You notice they get graphed with solid lines because it's less than or equal to, both of them. And I find that it's easy to, I personally enjoy graphing them this way using the table, choose x to be 0, calculate 10. Choose y to be 0, calculate 20. Here, same thing, choose x to be 0, calculate 16, and go back as well. And they just give you nice and easy points, especially when they're in this format. So you have these two lines that get graphed, and notice they intersect right here. It's important to find the point of intersection because it's later going to be used as a test point. So if you want to find the point of intersection, then you use our Chapter 9 learned skills. Like I think what I did here was I multiplied the bottom equation by -3 to get this. And then, so when I multiply the bottom equation by -3, the x's dropped out, and we had -3y plus 6y is 3y, solve it, you get y equals 4, and therefore x equals 12. So the point is 12, 4. Oh yeah, I had to, graphing the lines is one thing, but then you also had to test the region to see which side you get shaded on. And the point 0, 0 gets satisfies both the blue and the green inequalities. So that means I shade below each of these in the region that contains 0, 0. And the part that gets shaded twice is right here. Now I will say that because of the nature of this problem, x and y cannot be negative. You can't choose, even if it were somehow beneficial, you can't somehow choose to do a negative number of multiple choice questions. You can't even do a decimal amount of multiple choice questions. So like 1.5, you can't do 1.5 multiple choice questions. You can't do -3 multiple choice questions. So all of these the possibilities, the solution, whatever it's going to be, has got to be a positive integer. It's got to be a natural number, really, is what they're called. Or a whole number, really. I guess you could, theoretically, if it were advantageous to do 0 multiple choice questions, then you could include x could be 0 or y could be 0. So then we'll call those the whole numbers. Your solution has got to be a whole number. So therefore, we don't actually, maybe I shouldn't even needed to shade this bottom part or this part over here. In any case, this is the region that follows all of our constraints. So if we were to pick an x and y value corresponding to any point inside this quadrilateral, then it would satisfy all of our conditions. So we have all these options. You could do this point here, which is I think 2, 6. You could pick two multiple choice questions and 6 free response questions. That'd be fine. That would satisfy all of our conditions. So really, we have this flexibility, but what we really want to do is maximize. So of all the different possibilities, which one is going to give us the greatest number of total points? Remember that we get 10 points for each multiple choice and 15 for each free response. So instead of picking and choosing all of these and testing them all, what the theorem really says is that actually you don't need to pick all of them. Just choose the maximization is going to come at one of the vertices. So you have to test the vertices. There are 4 vertices to this quadrilateral. 0. If you choose 0, 0, you're not going to get any points at all. So that's not good. This vertex 0, 10 gets tested here. So if you choose 0 multiple choice questions and 10 free response questions, you get 150 points, which is not bad. 16, 0. If you choose, so this is like going whole hog on free response questions, which is not a bad idea because you're getting 15 points for them, so you get 150 points that way. But if you go whole hog on multiple choice questions, that might be better because you can do more of them, like you can do 16 of them. But so then actually you get 160 points for doing that. But actually, what gives you the most points is kind of a blend between the two. This vertex right here is 12, 4, and so if you choose 12 multiple choice questions and 4 free response questions, you see you get a total of 180 points, and that is our maximization. That's the point that gives the maximum total score. So if you think back into the World War II context, it's kind of like how many troops should I load up on the boat versus how many bags of gear should I load up on the boat. We've got lots of options, we've got lots of constraints, and we've got some sort of algorithm for maximizing this. And so that's how they decided how to ship things across the Atlantic Ocean in preparation for D-Day. Let's do another one. A company, this is example 14 from your textbook. A company manufactures motorcycles and bikes. To stay in business, it must produce at least 10 motorcycles each month. But it does not have the facilities to produce more than 60 motorcycles, 120 bicycles, or a total of 160 of either. The profit on a motorcycle is $134, and the profit on a bicycle is $20. Find the number of each that should be manufactured in order to maximize profit. So here's the roadmap. We're going to do knowns and unknowns, produce and take all of these statements and turn them into inequalities and equations. One of them is going to be our maximization. We're going to graph them. We're going to shade things. We're going to find vertices. And then we're going to test each of the vertices to find a maximum profit. So that's the big picture of what we're going to do. The unknowns, notice I again labeled as X and Y because I know I'm going to eventually have to graph them. So all the more reason to write it out. X is going to be the number of bicycles per month, and Y is going to be the number of motorcycles per month. Interestingly enough, these are interchangeable. If you had chosen Y to go for bicycles and X to go for motorcycles, for example, it wouldn't have mattered. So the choice is arbitrary. Again, it doesn't make any sense to try and make a decimal number of motorcycles or a negative number of bicycles or something like that. So we're only choosing the whole numbers. You could choose to produce 0 of something, but we're not going to be. But they're not going to be negative or decimal. So this condition, to stay in business, it must produce. This is the number of motorcycles. Could be at the very least 10. 10 is acceptable. It could be at the very most 60 here. So that's what Y ranges between. And you can see it even gets graphed here. Y at the most is 60, boom. Y at the least is 10, and they're both solid. X is going to be less than or equal to 120. That's this condition right here. Can't produce more than 120 bicycles. So that's what this line is right here. Notice that it's also solid. And then X plus Y is less than or equal to 60. That's or a total of 160 of either. When you add these two up, they can't be any more than 160. They can be less than or equal to. So that's this line right here, and you can see that I used this table to graph it. Choose X to be 0, choose Y to be 0, and then you get these points. There's a point down here. That's the point 160, 0, and you can't see 160, 0 up here, but it's up there. And then I knew which region to shade because I tested the point 0, 0, and it is over here. Here, there's also a shading going on. Y can be in between 10 and 60, so I'm going to shade all of these things right here, all of these values, all the red values in between the two horizontal lines. So between this condition, and this condition, oh, and also you can see the vertical line is 120, and I shaded to the left because this 0 does, the test point of 0, 0 does work in this here. So between these three different inequalities, we get, again, this, it's not a quadrilateral, it's a 1, 2, 3, it's a pentagon. And this pentagon has 5 different vertices. This vertex, these 3 vertexes, I think are relatively easy to find just from graphing. You know, this is just, if you know what this line is, it's 10, and this line is 60, and this line is 0, and this vertical line is 120. So you can kind of figure out 0, 10, 0, 60, and then 120, 10. These are a bit trickier to figure out, although they're each on vertical lines. So I know that this is 120. This is something, 120, something, and I can use this equation to figure out what the other value is. This point, same thing. The Y value is going to be 60, so I can use this equation. If Y is 60, then X has got to be 100. So finding the vertices is not too difficult here. I think the most difficult thing is organizing all your information and like taking the words. Honestly, the most difficult part is taking the words and translating it into inequalities and graphing them and making sure you understand you're representing them well, which is why knowns and unknowns is so important. But once you have all the vertices, then you can take these x and y values and plug them into your profit equation. And you can see we've got lots of different options here. You might think already, okay, just doing one of these vertices is not going to be maximum, but still you have these two right here. It's worthwhile to test. Between these two vertices, you might not know, like as the owner of the shop, right? Well, 100 of one, 60 of another versus 120 and 40 of another. I'm not sure which one will give us the more profit, but if you check, then you'll be able to find that actually 100 bicycles and 60 motorcycles is going to give us the most profit. And I want you to calculate what that is. While you're calculating what that is, there is an Academy Award-winning film called Chicago that I highly recommend. SEH performed Chicago in, when was it, 2019? And it was a lot of fun to watch the players put that on. It's a fascinating movie, really well done, really well performed, great singing, great dancing, great acting, and even great directing too, because of the way that they kind of took it as like the way they interpreted things. I highly recommend you go check it out, even if you're not a player, for SEH Chicago 2003 Academy Award-winning film. And you should then also start 92, copy the problem list, and do the first problem, and I'll see you in class. Hey everybody, this is a quick tutorial on how to do linear programming. That is when it comes to like the pre-calculus subject of linear programming on Desmos and on the TI Inspire. So we did this problem in the notes, example 14, accompany manufacturers, motorcycles, and bicycles. Great. Let me show you how to type in the inequalities. You can just type them in 10, and then you can actually go on, typing on the keyboard, less than, and then the next keystroke is equal to. So, and then delete, less than, equal to. That's what that looks like. Y less than, equal to 60. Here's the first one. X, we know X has to be greater than 0, so greater than or equal to X greater than or equal to 120, as it says right here. And then the third inequality is X plus Y is less than equal to 160. Okay, great. So we've got these, we've got the region. And then why don't we plot the points? I'm going to add a table, plus table. And instead of X1, Y1, I'm just going to type in X, Y, and then 20X plus 134Y. And so we have 0, 10, and 0, 60. I'm doing this table over here, by the way, in case you didn't know. And then 100, 60, finding the profit values for all of the vertices on the pentagon. 120, 40, and then 120, 10. I'm just hitting tabs. To go throughout the table, I'm hitting tabs and arrows to do that as keyboard shortcuts. Great. One other thing, so you can see here, this is the highest profit, and that's at 100, 60, which is right up here. One other thing you could do, an alternate, would be to just do A, B, and then add the slider, and then say you wanted to calculate the profit, 20A plus 134B, and then you can just drag this point around wherever you wanted to, and it would give you the profit. You can see it's high, really high here, and going down here, down to 7,000, down to 2,900, and these are all possibilities. But the maximum profit is going to be at one of the vertices, this one right here. Now, how to do it on the TI Inspire? It would look kind of like this. First, let's start off at the very beginning. Graph. I'm just going to do a scratch pad, a graph. This would be, so I'm going to type in, instead of using the trackpad, I'm going to use keyboard shortcuts wherever I can. B, and then let's type in a relation. We don't want to, menu, and then 3, and then 2, relation. The relation is, now, I kind of wish I could type in 10 is less than or equal to y is less than or equal to 60, but I can't type more than one inequality symbol. So I'm just going to go y, and then control equals brings me up this little menu right here. I want less than or equal to 60. Again, that was control equal. You can see it in blue right here, all the different inequality symbols. And then enter. And then all of a sudden the entire screen went blue. And that's because I'm really zoomed in. So I think what I want to do is I'd rather have a window that looks more like this, going up as high as 100 and as far right as 200. So I'm going to do that on the menu 4, window zoom, and then 1, window settings. And the X minimum, I don't need it to go any lower than 0. X max goes up to 200. Y min, don't need to go any lower than 0. Y max, call it 100. Okay, and there it is. You can see it even labels the y as less than or equal to 60 region right here. I'm just going to press tab to easily get to the next relation number 2, and that's going to be this one right here. X is control equals less than or equal to 120. Enter. And there it is. Tab for the next one. You can see I'm typing in relation number 3. X plus y control equals, that will be the less than or equal to symbol, and then 160. Enter. There it is. There's the region. You can see it's a pentagon. Now, how do we do the profit? Well, first we have to find the points of intersection. Menu, analyze graph. I would like to do intersection, but it actually doesn't work on relations very well. So I'm going to instead just do a trace. So it's not in 6, it's in 5, trace. And graph trace. Now I'm just going to use the up, down, left, right arrows. If I want to move along a particular relation or a curve or a graph, I can use left or right. But if I want to cycle through between the different relations, I have 3 different relations there. This is relation 2, relation 3, and relation 1. I'm just pressing the up arrow over and over and over again or down arrow to cycle through the different relations. You can see and then scrolling left or right, or pressing the arrow left or right. Aha! There's a point of intersection, 120, 40. Here are all the points of intersection. Here are all the points of intersection, and you can find them on the TI Inspired by tracing. You're not going to get it exactly. You're going to have to eyeball it up a little bit because we're just tracing one curve. It doesn't know where to stop for the other curve. But this is just one way to do it. This is the intersection point 100, 60. Now, how to find the profit. This third column right here. So once you've found all the different points of intersection, then you can go, we're just going to dispense with this graph. And what we need is tab, 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 tab. We need a table, a list and spreadsheet. So enter, and I'm going to type in my data points. Points of intersection. 0, tab, 10, enter. Actually, I'll just do all the x values first. 0, 0, I'm hitting enter. 100, enter. 120, enter. 120, enter. All right, right arrows to go through, and then 10, 60, enter. 60, enter. 40, enter. 10, tab. Now C, if I want to put, you see this equal sign right here. This equal sign means that up here I can type in a formula. So I'm going to type in the profit expression here, 20, and then shift A. Notice this is a capital A, so this will also be a capital A. 20A plus 134 shift B, capital B. Enter. Boom. And that gives us all the different profits. You can see that this one is the highest, $10,040.